Hi, welcome to nETSETOS. In this video, we will discuss about longest common subsequence. I have also made a video on subsequence. If you have a minute problem in understanding any of the concept of subsequence, you can go through it. So in this video, I'll go through by recursion, by memoization, and then by dynamic programming. And I will tell you why we are going for memoization with its coding. So let's know what is subsequence. Here we have been given two strings x and y, where in x we have EG and in y DEFG. Now if I have to take out subsequence, I need to take out the common letters, which are E is common in both, G. But the main point over here is when we match this E with the Y string, E should come forward to it. Let's say if I have the example EG and in Y it is G, F, E. Then E is the subsequence, but G is not the subsequence because it should lie ahead of the position over here. It can be ahead or at the same position, but not at back position. So this point we need to keep in our mind. So let's go ahead and firstly we will understand this by recursion. Here we have a string x, EG and the other string DEFG. I have this algorithm in front of my screen. I'll take these two strings and on the basis of this algorithm, I will solve it. Here I took E and D first letter of both string. I need to compare this E with D. Is it the length of X? That is whether I is at the last point length of X. If it is there, it should return 0. Or whether E and D are equal? No, they are not. So we will go for else condition, where it says to take firstly I plus 1 and then j plus 1, and out of these two take out the max. So here I'll take x1 y0. On the other hand, I'll take x0 y1. Here x1 is G, whereas y0 is D. x0 is E and y1 is E. Now we will again go ahead for GD. Firstly, I'll write all the combinations and afterwards I'll take the max of it. Now GD is neither equal nor they are at last part of the string. So here we will again go to else part and I'll take out x2 and y0, whereas on the other hand I'll take x1 y1. Now if I see, x2 is at the last length, that is it is satisfying the condition whether all the strings of x are finished. Yes, here they are finished. So here it is satisfying if condition and it says to return 0. Whereas here x1 is G and y1 is E. Now we will proceed for this. Here we will take out x2, y1. On the other hand, we will increment y as y2. x2 is at the len of x, so again it will return 0. So here we will get 0. Whereas x1 is G and y2 is F. So we will proceed for x1 y2. x1 is again for x2 and here y2. Whereas here x1 y3. x2 is returning 0, so here I'll write 0. x1 is G and y3 is G. Now we can see G is equal to G. So it will go for elif where it says 1 plus and the next letter of the string. So here I'll write 1 plus x2 and y4. x2 and y4 are at len of x and y, which is returning 0. So here recursion stops, and when I return, here we will get 1. Then out of 1 and 0, max value is 1. So here I'll write 1. Then we will go to GE branch. Out of 0 and 1, max value is 1. Then out of 0 and 1, GD will get 1. Now we are left with EE. Let's solve this. As EE are equal, so it will go for 1 plus the next letter of the string x1 and y2. x1 is G and y2 is F. Now if you look it carefully, GF we have already solved, but still this is a recursion, so we will solve here. x1 and y2 GF are not equal, so we will go for else part, and here we will write x2 y2 and here x1 y3. Here x values ends, so it will return 0, whereas x1 is G and y3 is G. Now for G value is equal to each other, so it will go ahead and will go for this return value where it returns 1 plus the next letter x2 and y4, where we get x2. This is the last letter, same on y side, so it will go for returning 0. Now from here value will return as 1. Then out of 1 and 0, max value is 1. Here 1 plus 1 is 2. So here we will get 2. Out of 1 and 2, max value is 2. So here we will get 2 value as maximum. So this is how recursion works. But here you have seen that we faced a problem for G and F, as it was firstly solved here and again I have solved for its another branch. This was the small string, so it came just one time. But for the longest string, it will have many of the branches, which is quite hectic, because if we have solved for one time, why to solve again and again? So this is where memoization comes in, where memoization itself says to store the value in the memory so that we can make use of this value at the next time, which we can use over here, so that if we get this GF value again, then we need not to solve for this GF. Already we have used this GF at the time of solving this. So let's see how memoization works. Recursion always works by top-down approach. Memoization also works by top-down approach. Let's see how it will work. Here we will make an array. We have the first string as ED and the second string as DEFG. Now I have taken an array which is 0, 1, 2, 3 up to 3 index, whereas 4 is for its len of y. That is, it ends over here. Similarly for len of x as well. Now we will fill this array, and here I'll follow post order. Post order, hope you remember, we have studied in binary trees. During the traversal of the tree, when I visited last time, I will fill this array. So I'll go ahead, GD for the first time, this one for the first, second and the last time. So 20 comes first but its value is 0. So I will fill over here. Then I will go ahead. Here this is for the first time, second, and this is third time. So 2, 1, its value is 0. Then for the 2, 2, its third time. So its value is 0 over here. I'll fill this value. Then I will go ahead for 2, 4. 2, 4 is 0. So I'll fill this value 0. Then we will go ahead for 1, 3. 1, 3 value is 1. So I will write over here 1. Then for 1, 2, 1. Then for 1, 1, 1. Then for 1, 0, 1. Then it will go ahead and it will visit 1, 2. But you can see 1, 2 we have already filled over here. And we need not to fill this value again. This is where memoization comes in. Then for 2, 2, it's already filled. Then for 1, 3, it's already filled. 2, 4, it's already filled. Then we will fill for 0, 1. 0, 1 is 2 and 0, 0, 2. So this is how we have already stored the value in the array, which helped me while going for 1, 2, 1, 3 and 2, 2. So memoization is all about storing the value so that this storage can be made use in future. If we come to its coding, first we are supposed to make an array. Then the rest steps are same as recursion. The only thing we need to introduce array and we need to fill all the values in the array. So here we have solved this problem with the help of array whose length of x, let's suppose it m, and for y n. So we can say m cross n. Whereas if we go for recursion, it's 2 to the power n. Because here we need to solve each and everything again and again. This memoization saves the time and solves this problem in order of m cross n. Now let's see this problem with the help of dynamic programming. And we will solve the same problem. For x we have EG, whereas y we have D, E, F, G. So EG I have taken over here and D, E, F, G on the other hand. And with this I have taken first as an empty so that I can introduce 0, 0 on both of the axes. Now we will solve this with an algorithm where letter of one string when matches with other string, it will add 1 to diagonal. And if it doesn't matches, it will go for last row and last column. Whichever value is maximum, it will store the value. So let's see it practically, where we have E first. E is not matching with D. That means it will go for the last row, 0 and 0. Its max is 0 only. So I'll write over here 0. Now E matches with E. So it will take the diagonal element, which is 0, and add 1 to it. So that I'll get 1 over here. Now it will check E and F. It is not matching. So it will go for 0 and 1 and will check for maximum. 1 is maximum. Similarly for E and G, 1 is maximum. Then for G, D, 0 and 0. G and E, 1. G and F, 1. G and G are matching. So here it will take 1 plus 1 and we will get 2. So the matching value are 2 over here. Now if we look for the string which are common, we will go for this arrow which is pointing over here. Here it is pointing, so I will take the corresponding value G. Here the arrow pointing to 1, its corresponding value is E. So E and G are the longest common subsequence. Let's see this with another example. Here we have two strings X and Y. I have plotted over here. Now we will check this using dynamic programming with the same strategy. Here we will see for A whether A is matching with P. No. So it will look for the last row and last column 0, 0. So 0 will be the maximum value. Then A and Q 0, AR 0, AB 0, AR 0, AC 0, AE, UF. A is not there, so all values will be 0. Then we will go for B. Q is not matching, B is not matching with R. Now here we got B, so it will add the one value to the diagonal element, so that I'll get value 1. Now we will proceed further. B is not matching with R, so it will take the maximum value out of 1 and 0, 1, 1, 1, 1. Then for C, C is not matching with P, Q, R. Now here we will take the maximum value 1, 1. Now we got C matching with each other, so we will take 1 plus 1. And here we get 2. Then 2, 2, 2. Then D is not matching with P. 0, 0, 0. Neither matching with B. So we will get 1. R, C. Here 2. D is not matching with E, U, F. Then we will look for E. 0, 0, 0, 1, 1. Here we get 2. Now here E matches with E. So here it will point 2 plus 1. And this time we will get 3 value. Now it will check for E with U. No, no. Then for F, 0, 0, 0, 1, 1, 2, 3, 3. And here F matches with F. So that we will get diagonal value and plus 1. And we got the longest common subsequence value as 4. Now if we check the string for common subsequence, we just need to look for this blue color where arrow has been pointed. 4. Now we will look for its corresponding value, which is F. Then this 3, which is E. Now this 2, its corresponding value is C. And here B. So B, C, E, F are the 4 letters of the string which makes common subsequence. So this is all about longest common subsequence, which you can solve it by recursion, by memoization, and also by dynamic programming. And if you want to practice this, I have also made Fibonacci, which is by iteration, recursion, and memoization. So I'll recommend you to go through it. Here I have discussed it with recursion and memoization way. So with this, let's make a program on dynamic programming. Here I am on PyCharm and I have made a new file, longest common. So let's start by making function def. I'll take the smallest name LCS and 2 strings X and Y. First I need to make an array, 2D array. So Python has a little bit different syntax. So first 2 square brackets, 0 for I in range. Let's decide this as 10 and the other one for j in range 10. By default, I'll make it as 0. Now we will define for loop for I in range len of first string and the other loop for j in range len of y. In dynamic programming, there is one plus point. If you understood the concept, you can write its program in seconds. So here we just need to introduce two conditions. If xi is equal to yj, if they are equal, then this array tij will be having 1 plus the diagonal elements, which is I minus 1 and j minus 1. Otherwise, it will go for last row and last column. So tij will have the value max of ti minus 1 and j, and the other one tij minus 1, and then we will return the array ti and j. Let's take the string and then we will call the function LCS x and y. Now we will run the program and here we got 2. Similarly, we can check for the other strings. So this is how we can take out longest common subsequence. So with this, I'll be coming up with DP programs back to back. So hope we will meet in the next video. Till then, take care. Bye-bye.